Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. This is question number 9. We're busy with June 2025, question, paper 1, and this is question number 9. The question says given that f of x is equal to x cubed minus 6x squared plus 9x minus 4 is equal to x negative 4 multiply x negative k squared. The first question says show that k is equal to 1. So the first question, and now x negative k square. Must remember this is a polynomial expression, and this is the equation of the cubic function, and this is factors of this equation of the cubic function. X negative 4 and x negative k square, these are the factors. So now must remember if we need to show that the k is equal to 1. So if the k is equal to 1, then which means x negative 1 square. So which means the turning point at the same time x-intercept as well. So we count as twice. So we need to prove that this is the factor of this cubic equation. Now we're going to apply the factor theorem here. If I say f of 1, must remember we need to, now he already give you that the 1 is the factor. So which means if I'm gonna substitute x equal to 1 here, the answer must come equal to 0. Then which means x is, equal to 1 is a factor of this cubic equation. So now f of 1. So we normally we need to see normally we positive 1, negative 1, positive 2, negative 2, etc. We all of these we need to substitute into this function to, if the answer come equal to 0, then we say that is the factor. But now he already give us that x negative 1, which means positive 1 is a factor. So we just need to substitute to show that this is the factor. So now 1 cube minus 6 1 square plus 9 multiply 1 minus 4. Now I use the calculator, the answer become equal to 0. Therefore x negative 1 is a factor. I apply the factor theorem. Now, so obviously this is going to be a therefore x negative 1 square. So the turning point going to be a so it's going to be x-intercept at the same point is turning point as well. That's why x negative 1 square. 9.2 calculate the coordinates of the turning point of f. Second question, we need to find the points coordinates of the turning points of f. So obviously we need to find the first derivative of f of x to find the turning point, and then we're gonna first derivative must be equal to 0, and then we're gonna solve for x. Have a look here. So find the first derivative of f of x. So the first derivative of f of x gonna be equal to 3x square minus 2 times 6 is 12x plus 9. The derivative of constant is 0. Now the first derivative must be equal to 0 to find the turning point. Now so 3x square minus 12x plus 9 is equal to 0. Now set the first derivative equal to 0 to find the x coordinates of the turning points. Now how we divide by 3? So it's going to be x square minus 4x plus 3 is equal to 0. Now we're gonna factorize this trinomial. It's going to be x negative 1 and x negative 3 is equal to 0. We factorize this one because in the middle is negative, so both factors will be negative sign. Now, so solve for x going to be equal to 1 or x going to be equal to 3. So these are the x values of the turning point. Now I need to find the y value. So we have to substitute this x equal to 1 into the original function to get the y value. So f1. So place of first we're going to substitute 1. So it's going to be a 1 cube minus 6 1 square plus 9 multiply 1, and that's negative 4, and that will give me answer is equal to 0. Now I substitute 3. F of 3 is going to be, to get the y value of 3 cube minus 6 3 square plus 9 multiply 3 minus 4, and I use the calculator. That will give me negative 4. So now the turning point we have now, therefore x is 1, y value 0, and x is 3, y value negative 4. So these are the turning points. So we substitute f of 3 and we get the negative 4. So the turning point, x is 1, y value 0, x is 3, y value is equal to negative 4. So these are the turning points. 9.3. Describe the concavity of f at x equal to negative 3. So to describe the concavity, we need to find the second derivative. So the second derivative of this function will be, first derivative we have, the first derivative is 3x square minus 12x. So second derivative gonna be a 3 times 2 is 6x and minus 12. The derivative of constant is 0. Now, so the second derivative we have now. So we put now x equal to negative 3 into the second derivative. Right. So we're gonna second derivative negative 3 we substitute there. So the 6 negative 3 minus 12, I simplify, the answer is negative 18 negative 12, which is going to be equal to negative 30. Now, so the negative 30 we have negative 30, that means less than 0. So this is a less than 0. So if the less than 0, which means the graph which if the answer is less than 0, which means the graph concave down at x equal to negative 3. Now so we're gonna write the answer. Therefore f is so therefore f is concave down at x equal to negative 3, because the answer is negative 30, which is less than 0. So if it's less than 0, then which means the f is concave down. 9.4. Draw the graph of f, label all turning points and intercepts with the axis. 9.4 say we need to sketch the graph, and to sketch the graph we need turning point. We have the turning point, and we need x-intercept. So we do have the x-intercept, x equal to 4 and x equal to positive 1. So this is x-intercept as well as turning point. That's why we count twice, because x-intercept also a turning point. That's why we count twice. and the y-intercept we got -4. Now we can sketch the graph. So which mean I have turning point 1 and 0, 3 and -4. X-intercept I've got x -4 and multiply x -1 square, which means x equal to 4 and x equal to 1. And the y-intercept we got 0 and -4. All of these we have. Now we're gonna sketch the graph. So always what I do normally, I draw the graph first, then I substitute the point. Wherever I stand, the Q start from there. So first turning point, there we go. So this is the graph. This x is 1 and the other side is I can, so the x is 4 here and turning point is 3 and -4. So which means y-intercept is -4. So I substitute all the point here. I display all the point. Y-intercept, and this is a turning point, this is second turning point, and these are the x-intercept. But remember, the turning point and the x-intercept is a same place, so we count uh, x-intercept twice. So this is the graph. 9.5. Calculate the maximum vertical distance between F and H for interval between 1 and 3 if h of x is equal to -2 multiply first derivative of x. I'll show you how to solve this question. To understand the last question is very important. Say this is the graph of f of x we have. And if I need to draw the first derivative of this graph, which is going to be 3x squared minus 12x plus 9, then it's going to be look like this. The turning point of the cubic graph, x is 1 here, and the x is equal to 3. So the first derivative, x-intercept, are the turning point of the cubic graph. Now, and if I say I have to multiply by 2 this graph, what will happen? Say this is the first derivative, but this is a parabola. I need to find the x-intercept. Easy. X-intercept earlier we found already. So there you can divide by 3. It's going to be x squared minus 4x plus 3 is equal to 0. We're going to need to find the x-intercept, and it's going to be x -1. I factorize. It's going to be a x -3 is equal to 0. It's going to be x equal to 1 or x equal to +3. And I put back into the original function, which is now, if I want to draw the parabola, then this is the original function. If I have to put back here, and then y value 0, obviously if I put x equal to 1 here, is y gonna be 0, and x equal to 3 if I put here, y gonna be 0. So the x-intercept gonna be 1, y value 0, and x-intercept 3, y value 0. So these are the x-intercept of this graph. Now if I need to find the turning point of this graph of the parabola, then obviously I have to take the derivative of this graph, which is going to be a second derivative is equal to 0. So it's going to be a 6x minus 12 is equal to 0, and solve for x +2 12, and the answer going to be +2. So the x is 2, and now you need to get the y value. Obviously we have to put back into the, this is our original function because we're drawing the parabola now. So you're going to put back there to get the y value, f of 2. So what will happen here? So to get the y value, 3 2 square minus 12 multiply 2 plus 9, and that will give me -3. So the turning point of this graph gonna be a 2 and -3. Now that's why I say the turning point 2 and -3, and these are the x-intercept. Now we try the second. if I have to multiply by 2 this first derivative, then 6x square minus 24x plus 18. Let's do this one. What will happen? So must remember, now your original graph is this one because you multiply by 2. So now what will happen here? So now here you need to find the x-intercept. So you divide by 6, it's going to be x square minus 4x plus 3 is equal to 0. Eventually the same x-intercept going to be, if you want to find the x-intercept, it's going to be x negative 1 and x negative 3 is equal to 0. And you solve for x gonna be 1 or x gonna be equal to positive 3. So if I put back into the original function here, and because this is the first derivative of that, which we have to multiply that graph, to multiply first derivative. So when you put back, and x gonna be 1, y value 0, x gonna be 3, y value 0, because if you put in the derivative, if you substitute 1, answer gonna be 0, substitute 3, answer gonna be 0. Now, so these are the x-intercepts. Can you see the x-intercept don't change, but the but the turning point will change. Turning point, I need to find the turning point here now. So I take the second derivative of this graph, which is gonna be a 12x minus 24 is equal to 0. 12x become positive 24, x become 2. So that x is 2. Now I put back into the original function to get the y value. So the 6 multiplied 2 square minus 24 multiplied 2 plus 18. This is the y value. So now I'm going to use the calculator. So answer is negative 6. So the turning point, therefore the turning point will be x is 2, y value negative 6. Now, so I'm going to sketch this one now. So that this time x-intercept, remember this is the first graph, x-intercept. The x-intercept is 1 and 0, 3 and 0, and as well here x-intercept 1 and 3. Now turning point 2 and negative 3, there is turning point 2 and negative 6. So when you multiply this graph, and then the turning point will go more down. So the 2 negative 6 may be somewhere here. So the graph is gonna stretch vertically, but the x-intercept won't change. So when you multiply this graph by 2, and this is the equation, if you multiply by negative 2 first derivative, then this is the equation. So which means this graph is a reflection of this graph on x-axis, mirror of this graph. Have a look here. So this time it's gonna be the turning point of this graph is 2 and negative 6. So now this graph is gonna flip over, a reflection on x-axis, a reflection about this graph, mirror of this graph is gonna be a turning point, gonna be a y value gonna be a positive, but the x-intercept won't change. So now this is your h, because he said the h is equal to negative 2 multiply first derivative of x. If you multiply the first derivative by 2, and that become h. So this is the graph of h, and this is the graph of f. To understand this one, just roughly I draw for you, and I explain to you that you can understand what is mean of h. So we need to find the distance, so which means it's going to be a h of x minus f of x. Let's do this way. Let me show you how to solve this question. So must remember, I already explained to you about the h. So must remember, h is above f. So now we're gonna find the distance, vertical distance. So we're gonna say h of x minus f of x. Let me show you how to do. Earlier I showed you explanation of h, and now from here a real calculation start, which you're gonna show in exam. So the distance we denote with d of x. So it's gonna be a, we're gonna differentiate with respect to x to find the maximum distance. So it's gonna be a h of x minus f of x. Now we're gonna find the distance. H of x. And h of x I told you. So what is the h of x we have? H of x we got -2 multiply the first derivative. In the first derivative, -2, what do we have the first derivative? The first derivative was 3x squared and minus 12x plus 9. Remember, this is our first derivative. This is our first derivative. So now multiply inside become -6x squared. Negative become positive 24x and negative positive 18. So this is the equation we have for h of x. So now I'm gonna put back into d of x. So I need to put back this h of x into this equation. So h of x we got -6x squared plus 24x -18, and now minus f of x. So f of x we got x power 3, that's the equation of the f of x, minus 6x squared plus 9x and minus 24, sorry, minus 4. So this is f of x. Remember, this is given. This is f of x. So minus 4. So I'm gonna, this minus must multiply inside now. -6x squared plus 24x minus 18 minus x cube, minus minus become positive 6x squared minus 9x and positive 4. Now I can cancel some of the stuff. Negative and positive is gone. And what else? Nothing else. So we have now x power 3, rearrange also, negative x power 3, sorry, and then 24x and positive 24 and -9. Negative x cube plus 15x, I simplify, -14. So this is my d of x. So this is a cubic function. This is a minimum, this is a maximum. This is a minimum turning point, this is a maximum turning point. So we're looking at maximum. So to find this one, we need to find the first derivative. So I'm going to find the first derivative. I'm going to differentiate with respect to x. So it's going to be a -3x squared plus 15. The derivative of constant is 0. Now, so first derivative must be equal to 0 to find the maximum. So -3x squared plus 15 is equal to 0. So -3x squared positive 15 become -15. X squared is gonna be a 5. X become 5 square root, positive and negative. And I must remember the interval he said between 1 and 3. So the interval say x must be between 1 and 3. So we only can use the positive value. So I'm going to put back into the original function, which is a d of x, which is this one, to get the maximum distance. So now we're going to put this one into that equation. So it's going to be that's going to be my y value. So the maximum distance going to be equal to, now this 5, positive 5. I'm going to use the positive value, 5 square root cube plus 15 5 square root minus 14. I put back into this equation. Use the calculator. So I use the calculator. Answer is 8,36. 8,36. That's my maximum distance. That's the answer of this question, and this is the maximum vertical distance. So this is my final answer. Now, if you want, according to the question, to calculate the maximum vertical distance between F and H, so you decide F minus H, what will happen? Now you go for the calculation. This time you have H of X, and which we already got negative 2 multiply first derivative of X, and we got this one. Now D of X, F of X minus H of X. So you from the F of X you minus H of X. Now we don't know which one is above, which one is below, so we decide according to the question, first F then H. So F of X minus H of X. So this time then X power 3 gonna be a positive. So then this is my equation, and I take the first derivative. So the first derivative, I apply the first derivative, I find the X value, so by interval between 1 and 3. So this time my answer gonna be negative 8,36. So the maximum distance can't be negative. So I apply absolute or 2 vertical bar, or you can say modulus, and then this mean therefore the negative become positive, because this additive of negative 8,36 is 8, positive 8,36. The idea of absolute is that distance, it doesn't matter if you moved 8,36 unit to the right to get to the positive 8,36, or you move to the left 8,36 unit to the left to get to the negative 8,36. Absolute value only concern about the fact that you moved 8,36 units. So we can say that absolute value of negative 8,36 is positive 8,36. Absolute value always positive. I hope so you understand. So you can choose either way. I think so this is more nice. AP Math learner will also understand. So, or rather, you can, if you don't understand the first method, then you can do this one. Then you can take from F of X minus H of X. At the last, you apply absolute modulus and you make him positive. Please like and subscribe my channel. If you have any question, comment below. I will assist you. In next video, I will show you question 10 about the probability.